Oh, g'day, it's Mr. Bennett here. I just want to talk about your investigation this year. So I want to go through that and give you a bit of an idea about what we're looking to see you do. Remembering the investigation is your work, and so it's got to reflect your understanding of what's going on. So the task that we're doing here is looking at the turning points or the inflection points of cubic functions. So they'll be in the general form of ax cubed plus bx squared plus cx plus d, which is not unusual. So just an extension of that is what happens if you times that by a common factor of k. So that's what we want to do. We want to see what effect the k value does actually have on the particular on the cubic polynomial. All right. So now, part of the thing that we'll be expecting you to do is to complete this investigation in a written report, and so there's some information. So there's information regarding that. Alright, so there's information regarding it in terms of how you set that out. So clearly explain the reason limitations that the thing you're doing. So the question you're going to pose to guide through the investigation. So you want to be clear at the front what you're trying to do. So what you're trying to do is you're trying to see what effect the first derivative has, or the max min points at the horizontal inflection points, and then looking at the with the second derivative, looking at the non-horizontal, non-stationary inflection points. So when you complete your report, it needs to have an introduction. Alright, so you'll probably do that more at the end after you've actually done everything. So that's going to be talking about what you're doing, how you're going to do it, including the significance and features and the context that you're going to put this within. The method required to find the solution in terms of mathematical modelling. Alright, so an appropriate mathematical model strategy would be including the generation and collection of relevant data. Okay, in this case you'll be doing that probably using GeoGebra, I think would be the best function to use. Show your mathematical calculations and results in an appropriate way of doing that. So that would possibly meaning put things into a table to summarise them, but show the key mathematics as you're doing that. You do need to state conjectures, and you do need to test them. So it's that language that you need to be. Alright, so then also you need to analyse and interpret your results, and then you need to be talking about your limitations, right, to the original problem. So, and then it has to have a conclusion, relates back to the original problem, and then I'd be putting things in a bibliography or appendicing any extra working out that you're doing. Now, important thing is the investigation must flow. It must be like, I can read this and understand what you're doing, and it must make sense. So there's your obviously your performance standards. So here's the task that you're looking at here. So you get your introduction based on this, and that's just the general view of a cubic and how that might change. So part one, you've been given these particular functions to graph, and these are designed to try and give you an idea about finding your stationary points, your A, B points, and any points of inflection. So to do that, you need to obviously do your first derivative and your second derivative for that function. Alright, and you'll need to graph that, and you'll need to show the differentiation that you've done and how you found your critical points, your turning points, and so on. An important part of that would be to do a sign diagram to show that you actually explain what's going on there. Just an extension part which is not given to you, but we are looking for you to extend and go beyond the scope of what you've been told to do. So here's one example is for one of the functions, you could actually do the slope of the tangent at points around the inflection point. Investigate using technology how the slope of the tangent changes either side of the inflection point. So what could you conclude from that? Again, you can make a conjecture, and you could prove your conjecture, what you understand from that. In part two, you've been given this function here, right, that you need to actually talk about. So you need to do your first and second derivative. Again, the same sort of process as what you do in part one, but now you're using a generic function. Alright, so you're using unknown values of P and Q. So again, it's sort of doing that for a general term rather than for specific values. Alright, so that's the extension of that. And then obviously doing conjecture, talking about limitations of what P and Q can be. So what could they be? P, Q and R? Well, they could be 0. If they were 0, what would happen? Okay, if they were greater than 0, if they were less than 0, you could be exploring those concepts. So using words and mathematical calculations to explain what you're doing again. So part 3 is then going extending it to all polynomials. So if we did the same thing going back to our a, b, x, d, so making up a conjecture again based on what you've done before. And so saying what effect would A have, what effect would B have, what effect would C have, and D, and so on. And then talking about the value of K out the front as well. Alright, so that's sort of putting things together for the most extreme polynomial function you can have, where we don't know what these things are actually do to the function. Alright. Now, one of the things I do when I mark this is I actually have my little cheat sheet, what I'm looking for, so what I expect for students. So in part A, this is what I'm expecting you to do. Graph sketch with points A, B, C or G put on there. So I expect you to label your max min, stationary inflection points. I would expect to see a sign diagram for your first and second derivatives. I do expect to see that you would interpret the sign diagram, so telling me about the max min stationary points, the concavity of those points. I would expect you to find maybe the midpoint of something if you were going to look at the midpoint of between the max and min and maybe where the inflection point might lie. See if there's an investigation with that. Right? I would be expecting you to put some information like that into tables to summarise what you've actually found for all your functions. Calculate the slope of the tangent. Right? So if you're going to do that, I would expect to see that information put into a table. I expect you to discuss the significance of the non-stationary inflection points. So if you were looking at that, looking at the slope of the tangent, which one would have the greatest rate of change, right? So anything else that you've done that basically you could look at, right? So making a conjecture about the midpoint and the slope of the tangent, and talking about conjecture of obviously looking at your stationary points and inflection points. Alright, so I'll be looking at that. In part B, when you're working with your general function with the leading coefficient of 1, again I expect to see the differentiation and the sign diagrams. I would be expecting you to use the quadratic formula to find the roots of that, so you'll need to show that process. Discuss when the discriminant gives you appropriate solution, so you'd be looking at when that's equal to 0 or greater than 0 or less than 0. Alright, so I'd be talking about that. And again, you could do those tangent things again for that. And I would expect to see the sketches for those functions. So working in part C, where you've got your general function with the A, B, C, D, again, you're doing the same sort of things again. Then when I'm looking at your general formatting, I'm looking for things like, does it have an introduction? Does it have a conclusion? Alright. Have you done all your graphs? Do they have a sign diagram with them? Have you labelled them with your stationary and non-stationary points? Alright. Do you use tables to summarise your results? Is the language that you use inside your investigation consistent with, how an expert might write? Alright, so be looking at all those things, but again, it must flow, it must be precise, it must be logical, you must also explain your thinking and what you find. Alright, so that's really important. Now here's an example of a sort of thing that you might do in terms of using and presenting information. So in part A, let's say this is my function here, and all I've used for this is I've used and inserted object over here, and I've inserted this object using the Microsoft editor. Now I'll put a video up on on the Padlet for you on just how to do that using that, and it will make your life easy if you use this. So alright, so when you start looking at this, that's typed, that's from there. Okay, all of this information, when I've done my factorising and all that, basically has been done inside the equation editor. Right, it just makes your life a lot easier to present that, and then that's typed, stating what I've actually found. Over here, I've also got my second derivative, and again I've used that because it does the fractions bit really well for that. And so I've talked about my first derivative, and I've talked about my stationary points. Again, now I've used GeoGebra to actually graph this, and I'll do a video up on GeoGebra, how you can use that. Again, I've just done a print screen from here, and then obviously if I want to add it in a box, right, so I would probably insert a text box. Alright, so for here I'd go, just drag it over here, I'd say local max, and then I could go local max is at 0, 0. Now the good thing about this is I could then colour that however I want. I can format that box. So let's say for my maximums I'm going to make them purple. Right, I could make my right hand side purple just by using some basic formatting in Word, and then I could also insert an arrow that would allow me to point to that point. Alright, so I can then label my points on my diagram, and again I can format that. Just right click on that, format object, and I can again make that purple. Alright, so it looks really professional that you're doing there. Alright, and the good thing is now once I've got that there, I can just copy and I can paste that. You know, if every time I do a maximum on a diagram, I can have that. I could do the same thing with a minimum. I could type that now and make that a min, and then I can put my min values in, and then I can change the color of that to something else. I might make that red. Alright, so you get the idea that you can actually format and make things easier for your reader. Alright, so it's about doing that. Now that's just nice stuff to do. The key thing about getting a good mark in this assignment will be your thinking, your mathematical skills, and how well you do your conjectures and prove those conjectures. Alright, now obviously we'll be talking in class about this. You'll get some time in the holidays to work on this, and some time after you get back from the holidays. But this is the theory that you need to know for this topic, and so therefore, you know, it does make sense that you actually do the investigation and learn a lot about the topic that we're doing by actually doing the investigation.